So what we're working on today is quadratics written in intercept form. It's on page 189 to 193. And all we have to do is complete this investigation for this basic graph. Y is equal to x minus 5, x plus 3. And all we're going to do is we're going to substitute all the x values into this equation to get these sets of points. Now, when we've done that, we need to do our first differences in order to check it. So now we get 0 minus 18, which is equal to negative 18, and so on. Now, once we go and complete the rest of this first differences, what you're going to do is you're going to go and calculate the second differences, okay? Now, as you go through, you're going to see that there's a pattern. There's a difference of 4 all the way down for your first differences. Then, once we've done that, it gives you the idea that there might be a set of second differences. And if the second differences are the same, we know that it is quadratic. Clearly, the first differences are the same, so we're going to assume that our graph is not linear in that regard. So now, once we complete our second differences, we can clearly say that this is going to be a quadratic equation or a quadratic relation because we have the same differences. And you'll notice that the differences are positive. So this would actually tell us that our parabola opens up. Remember, when you subtract, anytime you're doing differences, you always subtract the bottom number from the top number constantly. And because this is positive, we assume that our graph is actually opening up. You can actually tell from that. Now that we've done that, what we're going to do is we're going to take a moment and we're going to set up the graph that we're going to use. Each of the numbers moving up and down will be going up by 2s. So every block will be going up by 2s. So I got 4, 8, 12, and 16, and 20. And then along the x-axis, we're going to go and increase the numbers only by 1 for each block. So when we take a look at the x's, we're going to start with -2, and we're going to go backwards. So we're going to get -2, then -4 on the second block, and the same going across. Make sure you also label your axes as x. Okay? Now let's go down on our axes, and we should start with, I believe, -4. And then we're going to do -8. Oops, messed up there. Got to go back and fix it. Make sure that -2 is changed to -4. All right, and we'll go through the rest of these, and we're eventually going to end up with our final number to be somewhere around either -32. No. Yeah, either -32 or -36 for our chart. Now, once you've got your basic graph set up, we need to start transferring the points from our chart, our table, onto our graph. And I believe our first point is going to be 1, -32. So let's take a moment, zoom out, and then we're going to plot all these points. So this is going to take a little bit of time, guys. Sorry. So at -32, we're going to plot our first point for our y value, and it's going to be at x is equal to 1. And then I'm just going to keep going for only 1/2 of the parabola. So the next one is going to be 2, -30, and the next should be 3, -24, and then the next point should be 4, -14, and then I skipped that. I could actually add that point, but I chose not to. You can add that if you want. And now we have the general parabola going on here. Now that you've done that, we could literally, if we want to, draw our axis of symmetry. And I like to do that. So let's see what that looks like. Our axis of symmetry is actually at x is equal to 1. And now, remember, x is equal to 1 is actually part of our vertex, right? And what we're going to do now is we're going to go and map or mirror those points directly across the axis of symmetry. In doing so, you're going to get something that looks like this. And last point should be -418. And we're good. So now I'm going to draw half of my parabola, and then I'm going to draw the other half of my parabola to emphasize that we have an axis of symmetry for which we've mirrored 2 points. Now, just make sure you label your equation as well. It's always a good thing. Always do that. You'll always get some form of mark for labeling your parabolas if you ever have to graph them. And now, the bottom of our parabola is the vertex, and its point is 1, -32. Now let's go and answer some questions about these graphs. So the first thing that we need to take a look at is how the X-intercept relates to our basic equation. So you look at the X-intercepts. We're going to take a look at that, and we're going to take a look at how they match or show up in the equation. So let's just quickly identify them. So in this case, the X-intercepts are 5 and -3. And I've actually taken a look at my chart, and I identified them and just read them right off. All right, you see them there? You just say x is 5 and -3. And you'll notice something weird is going on there. Basically, the X-intercept of both of them are just what's opposite of what's inside the brackets. So if I have x minus 5, my X-intercept is x equals 5. And that comes about by this thing called the zero property. We'll talk about it in class one day. But right now, all you have to do is accept that rule. The next question that we have to take a look at is, what are the coordinates of the vertex? And we found the coordinates of the vertex to be 1, -32. Now, the key concepts that we should get from there is that when we were doing our table of values, we noticed that the second differences were positive. So our graph opened up, right? And because they were positive, they opened up. Now, the next concept we should realize that when we're looking at the graph, the axis of symmetry is exactly halfway between the two x-intercepts. Now, that literally means, if you think about it, mathematically speaking, if I have two numbers separated, it's just and I need a number exactly halfway, it's just going to be the average of those two. And that's why we say the axis of symmetry is x plus 1 plus x plus 2 added and then divided by 2, right? And then we can take that axis of symmetry, and then we can use that axis of symmetry to actually find our y value in our original equation, to find either the maximum or minimum, or otherwise known as the y value of our parabola. All right? Now, just understand, when you see this, just understand you can use the axis of symmetry to find the y value of the vertex just by substituting it directly back into the equation. Only another couple minutes to go for this first page, guys. So now, let's go and summarize all the concepts that we were looking at in this problem. The key ideas of a parabola are this. Anytime you have this parabola in this equation, the intercept form, we can find the x-intercepts by just simply using the opposite world for that. And the reason why that comes about is because of this thing called the zero property. So imagine if we let y is equal to 0. That means 0 is equal to a x minus r, x minus s, blah, 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 all equals 0. So that means either we have a is equal to 0 or x minus r equaling 0, or the x minus s equaling 0. And now when that happens, we can easily solve for our x values. Okay? So in this case, the one we have x minus s equals 0, and then the other one we're going to have, well, x minus r equals 0, which means x equals r and x equals s, just like we predicted by our observations. So just use opposite world for anything that's inside those brackets. Now, if you look to the right, I'm giving you an example for which we know that our parabola opens up, and that's only when our a value, that's the same value that you had in your vertex form of the parabola, is greater than 0. It still works. And when we have our r and s, if a was less than 0, it would still pass through those points. That's why I'm showing you that little graph with the vertices on the right side. So there's two possibilities, the red parabola or the other parabola. Now there is two more technically ideas that could pop up, but we won't talk about that. So right now we'll just understand this possibility. All right, now just remember that when we do this, we refer to this as the opposite world solution for our x-intercepts, right? So just if you have x minus 5 inside your bracket, you're going to say x is equal to 5 as our intercept. Now, in order to find the vertex, there are two things that you need. So your vertex has the letters h and k, referring to our vertex form of the parabola from before. In order to find the x value of our parabola, we need to know the axis of symmetry. And what we have to do is we have to say x is equal to x1 plus x2 or r plus s. Doesn't matter. All you need to know is that you need to take your two intercepts, add them, and divide by 2. You get a number. Then what you do in order to find your y value is you're going to sub what you got for your x value into the original equation, right? Now, just remember, it is the axis of symmetry. Now, the axis of symmetry allows us to find the y value by subbing into the original equation, okay? And you just have to just think of the axis of symmetry as nothing more than a set of averages of two numbers, okay? Now, we sub our values back into our equation, and we find our y value, and that will give us the coordinates, the total coordinates of our vertex, and we are done. All right, guys, proceed to part B. So now I just need you to proceed to part B. Just remember, with our vertex, we need to calculate our x axis of symmetry, and then take our axis of symmetry and plug it into our equation. Now let's go and try to work some of these out.